Hello, this is Tanmoy Deb from Agency Lab, Independent University, Bangladesh. Today I am going to present our paper on variational stacked local attention networks for diverse video captioning. So what's video captioning? A video has some events and these are explained by some sentences. The sentences are not same, but they mean the same event in the video. So why we care about caption diversity? Unfortunately, current approaches output a single rigid caption which never changes. Uh, we claim that we need multiple captions for one video because it can be explained in several ways in sentence in natural language. So here we can see one example that one video is having one output from the traditional models, and we want more than one. We call it sentence diversity. It can be useful for text to video retrieval, for example. So our main objective is to propose an end-to-end approach to improve video captioning. Then we are designing a pipeline for introducing sentence diversity inside that approach. And also then we perform extensive analysis in several datasets and also in diversity matrices to evaluate our model's performance. So first of all, we process the visual features. We have VGG, ResNext, Glowfast, etc. visual features. We actually apply local attention network in each visual feature set, and then we combine the visual feature sets by a feature aggregation network block. We call the feature sets as layers. We also introduce caption diversity by applying variational recurrent neural network, and which actually holds a extra latent vector z for diversifying the output, for changing the output based on the distribution z, and we change the output of pause because we know that the burst of speech holds basic syntactic properties of sentences. So we call it variational pause encoding network, VAPEN. So here's the primary architecture of our approach. We have the feature sets, we have the LAN blocks, fan blocks, and we have the VAPEN. The fan blocks are the final fan block is giving the encoding visual feature. The final VAPEN block is giving the pause feature. Both are used for decoding the sentence, the diverse captions. So to train the model, most people use cross entropy loss. Recently, the reinforcement learning based self-critical sequence training has been popular. However, we combine both based on one parameter eta. So we use MSVD and MSRVDT datasets. So we can see one result that the shared learning loss, our proposed shared learning loss, has the minimal minimal loss, where we can also see that the value of eta when it's 0.3, we have the lowest loss in shared learning. So here are the quantitative results on MSRVTT and MSVD for our model, and it performs best of comparatively. And we can also see that our model works really well in diversity evaluation matrices. And here we can see that when we are shuffling the feature order or we are stacking the feature order, identical features, the performance are changed. So here is one example for qualitative example for to see the feature stacking. Here you can see the ground truth for this video, and when we are adding more layers, we are seeing more meaningful sentences. More layer means more feature sets, and also we can see that when we are sampling more pause to generate the captions, it's generating different sentences, but they're meaning the same. They're having the same meaning of the event happening here in the video. And here we are seeing the qualitative result on diversity. Basically, for each caption, each predicted caption, we have the pause here colored, and we can see where it's putting the spatiotemporal attention. So for each of the diverse caption, we can see that it's focusing on several regions of the video. And here we can see some ground truths to evaluate. And for most of the cases, it's the same. And we can claim that our approach is learning in such a way that it can produce diverse captions because it can attend to different locations of the video, and it is also performing well in several cases. Thank you for viewing.